All right, so we still have these complex solutions. What does that mean? Is this overdamped, critically damped, or underdamped? Underdamped, yeah. And what's our homogeneous solution?
Let's C1 E alpha t cosine beta t plus C2 E alpha t sine beta t.
Right, so what's our alpha and beta here?
-3 and 1.
So -3, the real part is alpha, and the imaginary part is beta, so this is C1 e to the -3t sine t plus C2 e to the -3t cosine t. Or I'm going to just factor out the exponential part, so e to the -3t, and then in the parentheses C1 sine t plus C2 cosine t. What do we do now? We have our homogeneous.
Find the particular.
Yeah. What form does the particular take on? What do we look at?
Isn't it cosine first and then sine?
Oh yeah, it could be either. I mean, we could switch it, but it really doesn't matter. We just have a constant times cosine and a constant times sine. It'll work either way. Yeah. So what form does the particular take on, and what do we look at to figure it out?
Look at the forcing function.
Is your mic on?
Look at the forcing function.
Yeah, we look at the forcing function. We have to look at the forcing function and the homogeneous, right? Because if the basic form that we pick for the particular were already included in the homogeneous, we have to add a factor of t that can affect it. But the first thing we want to look at is that forcing function. It's a cosine. So what is the form of the particular?
A sine 4t plus b cosine 4t.
Great. right? So just a multiple of cosine 4t and a multiple of sine 4t. We're not in a situation where either of these parts is included as a part of the solution to the homogeneous. We know that for two reasons. One, the arguments inside the functions are different, but even if they were the same, right? Even if these arguments inside the functions in the homogeneous were both 4t, it still wouldn't be just a straight up multiple because these guys have a factor of e to the negative 3t. So we don't have to worry about adding a factor of t. These are our, this is the form of our particular, and now we could find our derivatives. We want to find x prime, x double prime, plug things in to try to figure out what those coefficients on sine and cosine are. So that won't be terribly bad because no product rule required here. We get 4a cosine 4t minus 4b sine 4t for the first derivative, and then the second derivative, I'll just go again. Negative 16a sine 4t minus 16b cosine 4t. And now we get to plug these in. So our equation is x double prime plus 6x prime plus 10x. So this is going to look like x double prime minus 16a sine 4t minus 16b cosine 4t. And then we're going to add 6 times the first derivative. And then add 10 times xp. So that's a sine 4t plus b cosine 4t. So when we add these, we could tell we're going to get some coefficient on sine 4t plus some coefficient on cosine 4t. And we just want to figure out what those are. Maybe what we'll do is figure out what the, maybe start with the sines. And then don't forget when we need to distribute a factor through. So for the sines, we have, I'm going to start at the top, negative 16a. Then in the middle, I've got 6 times negative 4b, which is negative 24b. And at the bottom, positive 10a times sine 4t. And for the cosines, negative 16b starting at the top, plus 24a plus 10b. Let's combine like terms in the coefficients. So we've got negative 6 minus 24b times sine 4t. And then for the cosine coefficient, we'll have 24a minus 6b. So this is what we have here is equal to this x double prime plus 6x prime plus 10x. That's what this is. And we know, because of the given function and our forcing function, that this is equal to 25 cosine 4t. What does this allow us to do? Like, where do we have a single equation right now with two unknowns that we're trying to find.
We compare the coefficients.
Yeah. Yep. So, like, the coefficient on cosines have to be the same on either side. The coefficient on sine has to be the same on either side. So, maybe I'll do some of this coefficient work up here before we spill on to the next page. We know that 24a minus 6b has to be equal to 25 based on the coefficient on cosine. And we know that, oh, that says negative 6. This should say negative 6a in the beginning. Sorry about that. We know that negative 6a minus 24b should be equal to 0 because I got no signs on the other side. You could take your favorite technique for solving these equations. Let's say, actually, you know what? I'm gonna not be stingy. I'm gonna go ahead and give myself plenty of room on the next page. I'm going to scroll down. If you need me to scroll back up at all, let me know. I'm just going to kind of move some of this onto the next page. So 24a minus 6b equals 25. And then negative 6a minus 24b equals 0. And this is, I think, pretty convenient to do algebraically. I'm going to leave the top equation unchanged. I'm going to multiply the bottom one by 4. So we have negative 24a minus 24 times 4 is 96. I'm actually going to check my arithmetic because I don't want to have to go back and do that. Yeah, 90. Okay. Now we'll add these together. Those a's will cancel, so we get minus 102b equals 25, which gives us b equals negative 25 over 102. And if we just, I don't know, plug this into one of these equations, let's see, solving for a. So a is 24 times negative 25 over 102 divided by negative 6. (50 over 51). Okay, we've got those coefficients, so that means we know our particular solution, or in the context, it's what we call the steady state solution. A was our coefficient on sine. Okay.
It should be cosine 4t.
Oh, good. Good. That would be weird. That would be a weird function to get. All right. Now our total solution, or that for that position function, we get just by adding the homogeneous and the particular. So the homogeneous was e to the negative 3t times c1 cosine t plus c2 sine t. And now we know our x particular. That's looking pretty good. There's one more task ahead of us. What is it that we don't yet know that we need to find out?
C1 and C2.
Yeah, we need those constants. And the one bit of information we haven't used yet are the initial conditions. So let's go ahead and find x prime of t. We only need to go as far as the first derivative, which is good because this is a product rule and that could get messy. So negative 3 e to the minus 3t times c1 cosine plus c2 sine. Then plus e to the negative 3t times the derivative of that stuff is negative c1 sine plus c2 cosine. And then, let's see, 50 times 4 is 200, so 200 over 51 cosine 4t minus 100 over 102.
Plus, right?
Oh, yes, plus. Yeah, thank you. Sine 4t. Okay. Let's see. Does that look good so far? You guys been pretty good at sussing out errors before I get too far with them. So, okay. Let's factor out the e to the negative 3t. So then we have minus 3 c1 cosine t minus 3 c2 sine of t minus c1 sine t plus c2 cosine t. Oh, that would be 100 over 102. I'll just call that 50 over 51. And do just a teeny bit more simplifying in the brackets here. I'll gather my cosine terms and my sine terms. So if I look at the cosines first, we've got minus 3c1 plus c2 and then for the sine terms, minus c1 minus 3c2. Okay, we've got our derivative, we've got our original function, let's use our initial conditions. One of the conditions is x of 0 equals negative 0.5. So I'm going to use that up here in the x of t function. Negative 0.5 equals. Now let's see what remains. E to the stuff goes to 1. The signs are go to 0. So we lose that. We lose that. Cosine is 1. So we get C1 minus 25 over 102. And we can find C1 right away. So negative 1/2 plus 25 over 102. That's negative 13 over 51. The other initial condition we had was that x prime of 0 is 0. So plugging that into the derivative down here on this last line, I'm just going to strike out the things that I know go to 0. So the sine goes to 0. Everything else goes to 1, and so we're just going to grab those coefficients. We get negative 3c1 plus c2 plus 200 over 51. And we know the value of C1. So let's see, negative 200 over 51 minus 3 times 13 over 51. That gives us negative 239 over 51. And now it's all over but the shouting. We're just going to put it together to write out our position function. So C1 was our coefficient on cosine. So that's negative 13 over 51 cosine t minus 239 over 51 sine of t. And then plus our particular, which was plus 50 over 51 sine 4t minus 25 over 102 cosine 4t. Boy, that's a mouthful. When you're working on problems, sometimes they ask you specifically, like, find the transient solution or the transient part of the solution, find the steady state part of the solution. What would we identify? What's the transient part of the solution? The section on the left, that one with the e to the negative 3t attached to it, yeah, it's the homogeneous. We call it transient because usually, as long as those constants are positive, and they are in these spring mass systems, these will tend that part, the homogeneous, tends to 0 as t approaches infinity. And then the part that persists is the steady state. That's over time what the motion, what the displacement approaches. So that was pretty fun. Sometimes they'll ask you, sometimes when they ask you, like, just what's the steady state? Like, sometimes they'll just frame the question that way. And we know that means we need to find the particular, and maybe we don't have to put the whole thing together to find the, the total solution. However, make sure that you always find the homogeneous solution, because that can affect if we need to add factors in, right? If the basic form of our particular solution is included in the homogeneous, that's when we have to add a factor of t. So even if we know we just want the steady state solution, you got to start with the homogeneous just to make sure we get that part right. Questions? Okay. So what I want to do now is let's use this time, the rest of this time, to get started on the assignment. There are two problems. The first problem does have two parts, but they're just different initial conditions. So you will have already done all the hard work, and you're just going to find a different set of constants. It's not like two full problems, I don't think. And then the second problem is separate. The first problem, I think, is an unforced spring mass system, and the second problem is a forced spring mass system. You could pull it up on any connected device on Canvas. It is posted, and I'll put it up here on the screen. And actually, give me just 1 second. I'm going to close the recording and save the file, and then I'll put the screen right back up.